Sprawling complexes of concrete, steel, and industrial cooling systems now serve as the physical engine of the modern internet. These structures are the heavy hardware driving the current artificial intelligence boom. AI's explosive growth relies on a mathematical scaling law. Doubling capability requires 10 times the data. But this exponential curve is hitting a physical limit. It abruptly flattens into a ceiling that no amount of new hardware can push through. Researchers at Apple recently tested this plateau using a study called GSM Symbolic. They slightly altered the variables, changing a character's name or tweaking the numbers. When the specifics shifted, model accuracy plummeted. The data proves massive language models are not reasoning through logic. They are merely retrieving compressed, memorized statistical associations. Brute forcing millions of data points allows them to mimic intelligence, but it does not teach them how to think. Training these pattern recognition engines requires absorbing recorded human history, from digitized library archives to the scraped open web. This container represents the data wall. Humanity has produced roughly 300 trillion high-quality written words. Tech giants are burning through this finite supply, and soon they will have consumed every word ever written. A trillion-dollar industry operating on a mandate of endless expansion halts completely when its primary raw material runs out. Without new human text to process, the systems must operate in a closed loop, completely detached from the organic world. To solve the data shortage, developers are programming AI models to write synthetic text, which is then fed back in to train the next generation of models. A landmark Nature paper maps this. This bell curve tracks human data. The wide tails represent nuanced extremes. Training on synthetic data erases these low-probability tails. Minor errors compound, triggering model collapse, where outputs irreversibly degrade into complete gibberish. The engineered cure for the data shortage acts as a slow-acting algorithmic poison. To keep scaling, the industry is forced to abandon data volume and pivot to raw, brute force computing power. Scaling hardware takes the problem out of abstract mathematics and places it directly into the thermodynamic reality of the physical power grid. The latest strategy is called System 2 test time compute. Instead of generating an immediate response, the algorithm is allowed to deliberate and process complex prompts for hours or even days before answering. This bar chart reveals the inference inversion. A standard Google search requires a fraction of a watt-hour, but a model thinking for days scales energy costs toward infinity. OpenAI's inference spend recently hit $2.3 billion, 15 times the cost of their training runs. By 2026, global data centers are projected to consume up to 1,050 terawatt-hours of electricity. That volume of power would make AI infrastructure the fifth largest energy consumer on Earth, sitting between Japan and Russia. Anthropic projects that by 2027, training a single frontier AI model will demand 5 gigawatts of power. This would commandeer the entire peak power grid of a major metropolis for months and requires 200 kilowatt liquid-cooled server racks that push current engineering to its breaking point. Brute-forcing intelligence has collided with the laws of thermodynamics, creating a grid-breaking energy drain the planet cannot physically support. At a macroscopic scale, the global technology sector is inflating a financial and infrastructural bubble stretched to its absolute limit. By 2030, the exhaustion of human data, the decay of synthetic model collapse, and the infinite demands placed on the power grid will converge. This reckoning leaves the core technology intact, while ruthlessly bursting the financial bubble built on the promise of endless expansion. When the core mathematical equation of scaling drops to zero, tech giants face a single choice: radically change how they build these systems, or face bankruptcy. The solution exists down at the extreme micro level of computer hardware, inside the dense, physical reality of modern processing power. The only path forward is a shift toward what researchers call capability density. Developers must stop trying to build infinitely larger models. To survive, the industry will have to shrink the architecture to maximize its efficiency, achieving frontier performance with a fraction of the parameters and power load. For a decade, Silicon Valley operated on the assumption that software was entirely disconnected from the physical world. But the AI boom is about to relearn the oldest lesson in science. In a war between exponential algorithms and the laws of physics,
Physics always wins.